So now we've illustrated the PageRank calculation. But here's the next question. Does the method we just presented always lead to a unique solution? And the answer is not quite yet. There's some modifications that we have to make in order to be guaranteed that we don't either have no solutions or multiple solutions, each of which case isn't good because then there's no single consensus that we can come up with. So let's consider again this our example over here, and we've augmented it now with one link pointing to this node V over here. Okay, so now let's look at V for a second. V isn't pointing to anyone. It has no outgoing links, if you notice. So what does that imply? Well, remember as we said that a node has to spread its importance score to other nodes, right? So if there was one link over here, then this would be V. If there were two, then this would be V over 2, and so on, right? But that's not the case here. There's no spreading of any importance score at all. So the only logical conclusion then is that V has an importance score of 0 because he's not spreading to anyone. So he has no importance score at all because that's the only way that it'll stay consistent with what we just did. And now if V's importance score is 0, we see that V was aggregating its importance score from Z. So this is Z over 4 because there's 4 links, 1, 2, 3, 4. So now remember, V has to be equal to Z over 4 by our equations because V is aggregating all of its importance from this link. So if V is 0, then that means that Z has to be 0. So then now Z is 0. Okay, well if Z is 0, then that means that all these outgoing links have to be 0 because he's spreading all of his importance score equally to everyone. And so 0 divided by 4 is still 0. And, well, then what's going to happen? Look at Y. Y is spreading all of his importance score to Z, right? So since Z is 0, Z has to be equal to Y plus X over 2, right? And we can't have any of them be less than 0. So since Z is equal to 0, then the only conclusion is that both of these have to be equal to 0. So now that's saying that Y has to be equal to 0 and X has to be equal to 0. Which means that this link is 0, this link is 0, and if you can see, it's going to cascade through, and everyone's going to end up having an importance score of 0. So we call the problem was all started with this node V over here, and the problem was that V didn't spread its importance score to anyone, and we call V a dangling node because it's just a node that doesn't point to any others, and once you get to that node, you're kind of sunk because you can't go anywhere else, right? If you're following the web graph, you can't possibly get out. So the only thing that happens is that it leads to no solution. So here we have basically the only solution working is that all the importance scores are 0, which is the trivial solution. And so we have no, and we should say no meaningful, because technically 0 is a solution, having them always 0, but there's no meaningful solution here. There's no way to rank from our solution that we've gotten. So the way that we solve the problem of dangling nodes is that we assume that the dangling node points to every other node in the graph. So basically what we say is that we assume V has a link to W, we assume V has a link to Z, we assume V has a link to X, we assume V has a link to Y, and we also assume that V has a link to itself. So it has a hyperlink in there that points back to its own page. And by doing that, then we don't have this problem anymore because as our random surfer idea, once we get to V, then we can actually get out of V again and continue with that random surfing process.